let's get to build. So make sure that you are now on the project 4. Project 4 is the voting system. You will need to build a data structure to store your proposals, and then you will need to implement a few functionalities, which is creating proposal, querying proposal, so get proposal, vote on proposal, and get all proposal, which returns all the proposals. You have access to all the types in your types.motoko file, and that's enough for the project 4. You should not need more explanation. I'll give you 30 minutes because this one is slightly more complex than the one that we've done previously. We have access to the code of the previous project, and we have this section to complete. The function that will probably give you the most difficulties is going to be the vote proposal. I suggest to be very logical, step by step. Every check that you need to perform, you can make a list. And then if you need help, you can create helper functions, so private functions that you can use in your code to make your code block shorter here. Nothing complicated, it's just a lot of check and a lot of different scenarios. And that's it. Good luck, everyone. I see you in a few minutes. Okay, I'm back. So we are at the 30-minute mark. Now let's correct this project. Okay, so we need to follow those requirements. So we need to only allow members of the DAO to vote. The voting power depends on the number of tokens. Creating a proposal costs some tokens, so 1 token here. Member can only vote once per proposal, so we need to check that. Every time a member votes, we need to update the score of the proposal, and we need to approve proposal at 100 or more and reject proposal at minus 100 or less, and approved proposal are automatically executed. First thing to do is to create a data structure to store our proposals. Here we can choose the data structures that we want. There is no requirement to implement a hash map or a tree map or a buffer. So you can choose whatever you want. I'll go with a tree map because we haven't seen the tree map yet. The tree map is very similar to the hash map. It's exactly the same methods that are implemented. It's the same interface. So all the functions that we are familiar with the hash map, like .put, .size, .replace, .get, and so on, they also exist on the tree map. The tree map is just using a tree found in the tree module. And you can take a look at how the tree is done. It's a binary tree where the positions of the element are determined using the hash of the elements. Yeah. The class tree map exposes the same interface as hash map. The only difference that I know of is that, well, generally tree map is slightly more performant than hash map, but it depends on the cases. And also there is a difference in how you instantiate the tree map. So the difference is that here you don't need to specify the initial capacity. I'm going to create a proposal ID that will be used to count my proposals, and I will initialize this to 0. Also, I believe that we have in types.motoko, we have access to, yeah, the ID is a NAT64. So I'll go for a NAT64 here. And then my tree map will be treemap.treemap. So each ID will give me an associated proposal. So my keys are going to be NAT64 and my values will be proposal. And so I need NAT64.equal. And for my hash method, I need to take a look into the NAT64 module. And I need to check if I have a function that can convert a NAT64 to a NAT32. Because the NAT32 is going to be a hash. Well, what I could do, I could use to avoid, because if I do that, I'm going to trap on some cases. If I do two NAT32, I'm going to convert my NAT64 to my NAT32, but I could trap in some circumstance. So what I could do is use two NATs. So NAT64 to NAT. And then this, I would use hash.hash, which is a method that takes a NAT and returns the hash. If you remember, this was in the hash module. Here, this one. And I need to import the hash module. What am I missing here? Yeah, I think it's just the syntax, so I need to. Yeah, okay, so it's gonna be correct like this. So essentially I'm defining a function that takes first convert this to a NAT and then put this into hash.hash. Hash.hash is deprecated, but it's just a warning and it doesn't mean that we cannot use it. So we still are able to use it here. Okay, so that's my data structure and I can move on to the second task, which is to implement create proposal. And so the parameter that we have is proposal content. And here I will need to know how to create a proposal. So let's proposal of type proposal will be ID, will be the proposal ID that is here. So this one. The content will be the content that is passed as an argument here. And in Motoko, we can shortcut that using this syntax. So content, just like this, it's essentially meaning that the field content will be filled with the argument that is here. Then the creator will be the color created. We need to get the time at the moment this function is executed. So we can use time.now, which I mentioned yesterday is a module to work with the time. System time, so it's a value in, it's an integer that represents the system time since 1970 in nanoseconds. Keep in mind that the time on the internet computer is slightly strange in the sense that it's a distributed system with multiple nodes. So each node is going to have a different, even if with a slight delay, but it's going to have a different time on the node itself, on the machine. So the time is actually the system time, so the time of the IC, which is something that the nodes agree on. And it's the same time within the message execution. So even if you run some code and you, for example, you take time here and then time here, as long as it's within the same message, so the same message on the blockchain, it's actually going to be the same time that you see. So it's just a little detail to keep in mind. But for our case, we don't really need to worry about that. Okay, so created, executed will be null because we haven't executed this proposal yet. Votes will be initialized to an empty array, the score to 0, and the status to open. Now that we have that, we can store our proposal. So proposal.put proposal ID and our proposal. And we need to increment proposal ID because we need to move to the next ID for the next proposal. So we can do it like this. And we need to return OK. And we actually need to return the proposal ID of the proposal that we have just created. So be careful that it's not proposal ID, but it's actually proposal ID -1 because here we need to increment it for the next one. So we need after that to return -1. And this will never be negative because we start at 0 and we always make sure that this is executed before this one. So it should never be negative. And the fact that I never return an error makes me think that I forgot quite a few checks actually. So I forgot to check that we need to be a member before creating a proposal and also that we need to burn 1 token. So I forgot that. Check that caller is a member of the DAO. Check that caller has enough token. And here, actually burn tokens. We need to do that. To check in one line that caller is a member, I'm going to use the members data structure that is here. And so I'll do if option dot is null members dot get caller, then we can return an error. You need to be a member of the DAO to create a proposal. What is option dot is null? Option dot is null. Where is the option dot is null is a simple, it could also be done with a switch case or a if, but I like this one because it simply takes any kind of optional value and it returns a Boolean that indicates true if this is null and false otherwise. So here, if we have a null value, it means that the caller is not part of the DAO, and so we can return our error. Then we need to get the balance. So this one, we remember option.get ledger.get caller, and then 0. And if the balance, for some reason, is below 1, return error, you need at least 1 token to create a proposal. Well, and finally, we can burn some tokens. So one mistake that I see quite often is to do this, await burn, color 1. Yeah, like we could also do that. Or just, if we don't want to store the result, we can do ignore. This is a keyword that is useful. So essentially it's just calling this method and then ignoring the results. Which could work. So it's not necessarily a mistake, but it's really something that you should avoid, because here we are doing inter-canister call to our own canister. So we are calling our public method, but just like we would call another canister. And so we are actually having an asynchronous operation here, adding a lot of delay when we could actually just burn directly, maybe by using a private function burn that would be synchronous. So principal amount. This function would simply burn any amount that we specify to the principal, and it would be synchronous. We should note that it's going to trap if amount is above balance of owner. So we need to keep that in mind, but here where we are using it, it's not a problem because we have checked here that we have at least 1 token, so we can safely use it. Since we are not modifying the balance here, it should be, yeah, it should be respected. And we are good with the proposal, the creation of proposal. Now to get a proposal, it's going to be very simple because we return optional value. So we don't even need to implement a switch case or any kind of verification. We can just do proposal.get the proposal ID and then return that. So just like this. Let's do get all proposals since it's fairly simple, and we will finalize with the most complicated parts. Get all proposal is similar to get all members that we had in the day 2. So iter the to array of the proposals dot values. and this will return exactly what we need, an array of proposals that are stored here. Finally, to vote, this time we have quite a few things to check. So we need to check that the color is a member of the DAO. So if the color is not a member, we return this error. Then we need to check that the member has not already voted. Because a member can only vote once. Where did I forget the semicolon? I think it's just, yes, here. Yeah, and that's it. That's enough check. So then once we can vote, we need to compute our voting power, compute the new status of the proposal, and also we need to optional, but if the proposal is accepted, execute it. So check that the member has already voted on the proposal is going to be fairly simple. We can, actually I forgot something. Check that the proposal exists, because that could be an error that the proposal doesn't even exist. So for that, let's do a switch case, switch. And here I'm doing a switch case because I will need to access the proposal in case it's existing. So that's why a switch case is super useful. If I do a if I can do a if and check that the proposal exists, but then I will not be able to unwrap the optional value. So I will still be stuck with an optional value, and that's not what we want. So switch case is again the way to go. Case null, return error, the proposal for this ID doesn't exist. And in the case of a proposal, we can unwrap it. So what I mean by unwrapping is here optional value, and then here non-optional value, so I can actually access the proposal. Now, that's where I can check that the member has not already voted on the proposal, and I'm going to create an helper function that takes as voted, takes a principal and a proposal. So let's say voter and proposal, and returns, no, not asynchronous, it's gonna be synchronous. Return a Boolean. So I can add some comment to let people know what this function will be used for. Returns a Boolean indicating if the voter has voted on the given proposal. And for that, I can check inside. So the best thing to do is to check inside types. I can check that there is this vote object. So for vote in proposal.vote.values, I'm checking all the votes. If vote.member, so where here member is maybe not a good term, but essentially it means that the person that voted. So this is where the principal of the voter is recorded. If it corresponds to the voter, it should be it should be like inverse. I guess it's a little bit confusing because here voter should be member and member should be voter, but I'm hoping that you're still following and not being confused by this. We can return true. Otherwise, at the end, it means that we haven't voted yet. So if as voted color proposal, then we can return you have already voted on this proposal. And we can return an explanation mark just to say that we are very, very angry that the person is trying to vote multiple times. So now that we have done all our check, we can move on to compute the new proposal. So the new status of the proposal and the new voting power. For that, we need, what is wrong here? I guess that's just normal. Yeah. Let's voting power will be the balance, actually, so our token balance option.get ledger.get color 0. Let's balance, sorry, let balance, let's multiplier is equal switch yes or no. So here I'm using the switch case in a different like scenario than what we've seen so far. I want to have a multiplier to multiply my token balance to get the voting power. So yes or no represents true if I vote for the proposal and false if I vote against the proposal. So if we are in the case where it's true, the multiplier is going to be -1. So I can simply do this. It's going to be 1, sorry. If it's false, it's going to be -1. And in that case, I can, wait, what's wrong here? Okay. In that case, I can do let voting power is equal balance multiplied by the multiplier. So this will give me my vote score, which can be negative or positive, and represents both of my cases. New vote score is going to be proposal dot vote score. So the current proposal plus the voting power. And this works even if this is negative. So this is good. And now I need to compute the new status of the proposal. Yeah, so the new status is going to be, let's new status. We need to switch on the new vote score. And that's a lot of new variables. We could do helper function to make this code cleaner. So, well, actually, this doesn't work here. I need to use this if statement. So the new status, if the new vote score is above or equal to 100, then it's going to be accepted. So this case. If we are in the case, oops, where it's below or equal to -100, we are going to reject, otherwise just return open. Finally, so let new proposal will be ID is equal proposal.id, contents is equal proposal.contents, creator is proposal.creator. So we need to copy all of those fields because in Motoko, it's currently not possible to simply modify fields of objects. Our objects are immutable, so we cannot just modify a field like you would do in other programming languages. You have to rebuild a new object and then reallocate this object in your data structure. Created will be proposal.created. executed will be proposal.executed, which should be null, but yeah. The votes, yeah, we need to add our votes, so I'll deal with that later. And the status will be new status. One thing I forgot is let new vote is equal buffer dot from array. So I'm creating a buffer from the votes of the proposal. And then new vote dot add of my current vote. So this gonna be member is equal to color. Here I'm adding this object. Voting power will be, it's gonna be a natural number. So yeah, it's just the token balance here. And yes or no will be yes or no. So we can keep it like this. And here, buffer, but to array of the new votes. Definitely not the best code that we could write. But it should work. Then we need to store it. So proposals.put new proposal. And the ID has not changed, so we can still do proposal.id. Something is off apparently. Yeah, it was not, it's not the correct order. It's first the key and then the value. Okay, yeah, it's good now. And now we need to execute. So this one, I'm going to do an helper function because otherwise it's going to be too much of a code block here. Execute a proposal. And so to execute a proposal, I will switch on proposal.content, which is going to be a variant. Either it's going to be case change manifesto with the new manifesto here, case add goal with the goal here. And so, oh yeah, if we change the manifesto, we just have to change that. Simply do manifesto is equal to new manifesto. And goal is equal to new goal. No, goals.add goal, because goals is a buffer of text, so we need to add it. And then once it's done, we can do let new proposal. So again, we need to replicate all the fields, which is slightly annoying, but we just copy paste here. ID, content, creator, created. And the only one that we need to change is going to be executed. So here we can do time.now. And finally, we can return. And here, if the new status is accepted, we run this function that executes our proposal, and then we return OK. And finally, we are done, I guess, with slightly other way around. I don't know, someone's told me other way around. I don't know which was the... Okay. So yeah, we're done with it. So a lot of if, a lot of switch, and well, it's basically things that we've seen, but just getting a little bit more complex. Then it's about how we would structure that. I think it would be an interesting exercise to try to structure it better, maybe with better helper function. There is a syntax which I think is, let me see. I think it's proposal with, no, it's not like this. I guess it's like, yeah, I need to check. There is a new syntax that came up pretty recently where we can use a with to essentially create a new object. So like here we only need to modify one field. We could do a with that would copy the old objects and just change the with field that we need to change. So that could be super useful in a scenario like this one. Okay. I'm not going to deploy and test it. I'll trust this code. You also have the solution, which I believe is slightly different. Ah, no, there is something wrong actually. Here I forgot to do this. Make sure that we do that to store the new proposal. Let's move to the next session. So I'll close this Zoom session and we move to the next session. I hope that everyone has succeeded this project, or if you haven't, that you now see how you could have done it and it makes sense to you. If it doesn't, if anything doesn't make sense, let me know. And yeah, let's move to the next session. Next session is about how to trust a canister. So we'll talk about security assumptions and trust assumptions when we say that a canister is trustworthy. So I see you there.